Alright, so for our next example we have two concentrated loads located at 5 feet from either end. One is 5 kips and one is 10 kips. So let's do this with a graphic analysis first, and then we'll do the analytic analysis. So I'm going to label my spaces, and once again what these spaces represent are the intervals between loads and reactions. So A is the space between the 5 kip load and this reaction on the left we'll call R left. Now R left is only vertical because it's a roller. R right has the potential for a horizontal force, but we have no horizontal action, so that will be 0. So we have R left vertical and R right vertical. So A is the interval between R left vertical and the 5 kip force. B is between the 5 and the 10. C is between the 10 kip and right reaction vertical. If there was a horizontal reaction, then we would have yet another number in there. So we'll do this to a convenient scale. So we have 15 kips acting overall. Looks like a 1 to 50 will work on this as well. So I start off with point A, and I go down by 5 kips. So I simply follow the direction of the vector. So down here I go to 5. That's point B. And then I go down another 10. Take me to 15. That is point C. And so this construct here, this is known as the load line. And it represents the forces that are on the structure. Now point D is somewhere along this line depending on the magnitude of the reactions. So a load line always starts at one point, does all the applied loads, then goes back up to the starting point with the reactions. The reactions will balance the load. So the procedure here is to pick any point on either side and draw rays to that point. Which looks like that. And then we're going to transfer those lines to the line of action of the forces that are being applied onto the structure. So we've got 10 kips down here, 5 kips over here, so I start here until it runs into the next line, over here until it runs into the next line, and then over here. The closing string joins the start point and the end point, so slightly elevated from what I picked. So this becomes point D. Now point D I simply measure from my scale, and I'm showing about 9 kips. So that leaves me with 6 kips on the top because there's 15 overall. So this is a graphic way of doing our solution. Now let's do the analytic process. So we're going to create a coordinate system. I like to start on the left-hand side here and call that my 0 point. Now when we do this analytically, we don't need to actually show the object to scale because we're putting in the dimensions. What we need is the forces and lines of action. So I have a 5 kip force here, a 10 kip force over here, and a right hand reaction over here. So the right hand reaction is located 20 feet away. Five kips is located 5 feet away, and the 10 kips is located 15 feet away. So both of these forces have a rotational tendency about this left-hand point here in a clockwise direction. The right-hand reaction has a counterclockwise rotational tendency. So if I sum moments about the left-hand end equal to 0, I'll call clockwise positive. That says I have 5 kips at 5 feet. That's that load, that moment arm. It's positive because it's rotating clockwise, or I should say has a tendency to rotate clockwise if it was not restrained by the right-hand reaction. I've called clockwise positive, so that's positive. Same thing for the 10 kips, so it's 10 kips at 15 feet minus our right vertical at 20 feet, and that all equals 0. Kind of ran out of room there. So if I finish my equation, let me move this down here, slide up a little bit. Our right vertical is 150 kip feet plus 25 kip feet divided by 20 feet so 175 divided by 20 equals 8.75 kips. Feet are going to cancel, units are kips. So our right vertical, 8.75 kips. So that very closely matches our graphics here. The magnitude is going to be dependent. You can see it's actually just a little bit less than 9, so I would say approximately. To get the left-hand reaction, when you're first learning this, I would really strongly recommend that you sum moments about the right-hand side and do the same calculation, but it's also true. Sum of the forces vertical equal to 0. I have minus 5 kips, minus 10 kips, plus our left vertical plus our right vertical equals 0. That's an expansion of that equation. Sum of the forces vertical equal to 0. So I have the R right vertical now is equal to 8.75 kips. That leaves me with R left vertical is 15 kips minus 8.75 kips. Or 6.25 kips. And there again, that closely aligns with our graphics. So that's 2 concentrated loads.